Encana uses hydraulic fracturing to develop unconventional natural gas resources. This technological evolution is one example of how we apply innovation to responsibly develop this clean and abundant source of energy. Let's take a look at the horizontal drilling and stimulation processes that have made shale development possible at depths of at least 6,500 feet and up to 15,000 feet. A drill bit is mounted on the end of the drill pipe. As the bit turns and grinds away, a mixture of water and additives called mud is pumped into the hole to cool the bit, control bottom hole pressure, and flush the cuttings to the surface. The mud also cakes on the walls of the wellbore, keeping it intact and preventing any losses to the formation. This first part of the well, called the surface hole, is drilled well past the deepest fresh water zone from the surface. In fact, the main hole of the well is drilled thousands of feet deeper than any groundwater aquifer that could reasonably be considered a source of usable water. Surface casing is inserted into the drilled hole to isolate any fresh water zones and to serve as a foundation for the blowout preventer, a safety device that contains the flow of wellbore fluids. The drill pipe and bit are then removed. Then, cement is pumped down the casing and out through the opening of the shoe at the bottom of the casing. It is then forced up between the casing and the hole, sealing off the wellbore from any fresh water. This process protects freshwater aquifers by providing a sealed wall of steel and cement between the wellbore and the exterior. The pipe and bit are lowered back down the hole to continue drilling the vertical section of the well to approximately 500 feet above the planned horizontal leg. This depth is called the kickoff point, where the curve will begin so the horizontal section can be drilled. This depth is at least 6,500 feet or more below the surface. Up to this point, the process is the same as drilling a vertical well. Again, the pipe and bit are pulled out of the hole and a downhole drilling motor with measurement while drilling instruments is lowered back into the hole to begin the angle building process. The distance to make the curve from the kickoff point to where the wellbore becomes horizontal ranges from about 900 to 1,300 feet. Once the curve is completed, drilling begins on the well's horizontal section, called the lateral. Each section of the drill pipe measures 30 to 45 feet in length and weighs approximately 495 pounds. It takes over 350 pieces of pipe weighing nearly 87 tons to drill a 10,500-foot well. At various stages of drilling, the pipe is taken out of the hole for tool and bit changes and put back in. This process is called tripping pipe. When the targeted distance is reached, the drill pipe and bit are removed from the wellbore one last time. Steel production casing is now inserted into the full length of the wellbore. Cement is again pumped down the casing and out through the bottom of the casing, forcing the cement up between the casing and the wall of the hole, filling the open space known as the annulus. The steel casing and cement sheath around the casing wellbore add up to between 1 and 2 inches thick to permanently secure the wellbore and prevent hydrocarbons and other fluids from migrating behind the casing. This casing also provides a second steel and cement barrier at shallower depths where freshwater aquifers are present. At this point, the drilling rig is no longer needed. A wellhead is installed and the location is prepared for the service crew who will perforate, fracture, and prepare the well for production. The first step is perforating, or perfing the casing. In a horizontal well, a perforating gun is lowered by coiled tubing into the casing to the targeted section of the horizontal leg for the first zone. The perforating gun is fired using applied pressure, setting off a charge that shoots small holes through the casing in cement and out a short distance into the shale formation. The perf gun is then pulled out of the hole. Next, because shale is tight or compressed, the well will have to be hydraulically fractured. Hydraulic fracturing is an essential step in producing natural gas from shale. This process has been safely used by the oil and gas industry for over 60 years and is strictly regulated by provincial and state government agencies. Encana meets, or in many cases exceeds, these regulations. Hydraulic fracturing is where water, sand, and additives are pumped into the wellbore and down the casing under extremely high pressure. Encana is committed to working collaboratively with its industry peers, trade associations, fluid suppliers, and regulators to identify, develop, and advance hydraulic fracturing best practices. Encana does not permit the use of diesel and 2BE in our fracturing fluids. As the mixture is forced out through the perforations and into the surrounding rock, the pressure causes the shale to fracture. Similar to hitting a windshield with a hammer, it shatters in all directions back to the point of origin in a controlled fashion. This fracturing creates a fairway connecting the reservoir to the well and allows the released natural gas to flow to the wellbore. Next, a temporary plug is placed to the left side of the perforations for the first stage fracture. The plug closes off or isolates the perforated and fractured sections of the wellbore, so that the second stage section of the horizontal leg can be perforated and fractured. Perforating after the first stage is accomplished with wireline. Tight shale reservoirs do not contain adequate natural fractures for development without hydraulic fracturing. The fracturing process provides multiple pathways through which natural gas can flow more easily. With advancements in technology, multi-stage fracking has become the standard for tight gas reservoirs. It's an efficient and effective approach to developing these resources. This process of perforation and fracturing can be repeated several times to cover the entire horizontal distance of the wellbore. Once hydraulic fracturing is completed, the plugs are drilled out, allowing the gas to flow up the wellbore. The next step is to install the top section of the permanent wellhead, also known as a Christmas tree, and other necessary surface equipment. A pipeline is then built to transport the gas to market. Horizontal drilling greatly reduces our surface footprint. The well pads used for horizontal drilling occupy just 5% of the comparable surface area required for producing the same amount of natural gas with vertical wells. Thanks to the vision and persistence of those who have advanced these new technologies, shale plays across North America have become an innovative and highly productive source of clean, natural gas for our communities.